Welcome to Google Cloud's Global Digital Conference, Modernizing IT in a Cloud-First World. I'm Eric Bana, and I'm going to be talking to you about migrating to Google Cloud Platform. We have Googlers on standby to answer your questions, so please fire away on the left side of that icon and send your questions our way while I'm going. Evernote migrated to Google Cloud in 70 days. Lush, the British cosmetics firm, migrated to Google Cloud in 22 days. In this 40-minute session, I'm not going to migrate a company to Google Cloud. But what I will do is walk you through the phases of migration and show you how we have tools and processes available to help you at each step of the way. In particular, I'll focus on a lift and shift migration to Compute Engine. There are a couple of reasons for this. First, as you saw in Terrence's session before mine, there are a number of services in Google Cloud Platform. In order to provide some level of depth in just 40 minutes, we have to choose. And I chose Compute Engine because even for those companies that end up choosing, for example, our machine learning services or Cloud SQL or Spanner databases, they tend to also have virtual machines before moving to the cloud. I'll be focusing here on processes and tools and not our service offerings. So this session is more for those of you who want to do it yourself. If you're looking for Google Professional Services to help with your migration, my colleague Mark Aronica is giving a session in track 1, and he'll go over what our professional services organization can do to help you migrate to the cloud. I'll be giving you an overview of each phase of migration and a demo of selected steps. So we'll go through assessing, planning, deploying, and optimizing. Now, because we only have 40 minutes, there will be times where I skip ahead or don't show a demo of each step. But I want to give you at least the overview so that you know here's what to expect at each stage and how to do it. There are a number of different customer journeys to the cloud, ranging from building new apps in the cloud and leaving what you have on premises, or transforming what you have on premises, for example, moving to containers in your data center or colo, and then later migrating to the cloud, or moving your existing applications to cloud. And that's where we're going to focus in this session. And there you also have 3 choices to rewrite, re-architect, or run as is. I'm going to focus in this session on running as is. There are 4 different phases to migrate to cloud, and our goal is to meet you where you are and accelerate your migration. And we'll do that through assessment, planning, deploying, and optimizing. All right, let's start with assessment. So there are 3 main steps in the assessment phase. The first is discovering what you have. So for companies that already have a configuration management database or a CMDB, you may already have this step done. In the event that you don't already have an inventory of those applications and servers in your environment, there are tools that can help you, and I'll show you that in a moment. The second step, once you know what you have, is determining how to migrate that application to the cloud. And so there are 7 different assessments that you can come up with for each application. So you can categorize in one of these 7 buckets. On the far left-hand side, you have retain and retire. Now, these are 2 special categories that don't involve moving to cloud at all. For example, some companies have applications that have been around for so long and that they can't move anywhere. They have to be running on premises, whether it's for business reasons or for regulatory reasons, and you may choose to retain those. For the second phase, retire, it's common for companies when they look at their environment and they're assessing their move to cloud, that they realize there are some servers or some applications that have been running, but really don't need to continue running. And so you may just end up retiring those. The next is a rehost, sometimes called a simple lift and shift. In this case, if you're running either bare metal or virtual machines in your environment, maybe on VMware or Hyper-V, you can take that virtual machine, move it to the cloud, and you're still managing that same VM. You're still managing from the operating system and up, but now that VM is running in the cloud. And there are a few other options that I won't go into in this session, but I include for completeness, namely replatform, refactor, replace, and rebuild. So let's just focus here on a simple lift and shift migration. Next step, once you determine how you're going to migrate the app to cloud, is figuring out what it's going to cost. There are 3 ways to do that. First is using the Google Cloud Pricing Calculator. This is a calculator available on our website where you can enter in the shape of the machine, the number of cores, the amount of memory, the size of the disks, and we can tell you what that would cost to run in Google Cloud. If you're looking to get an estimate for your entire organization, a better option is to contact a Google Cloud customer engineer. Our team is happy to help you figure out what you have in your environment, what the options are for running in cloud, and what the costs and trade-offs are of each option. As Terrence mentioned in the previous session, there are a number of different services in Google Cloud Platform, and our customer engineers can help you figure out which service is the best match for your application and for your business needs. The third option is a set of assessment tools. If you are looking for a way to just scan your environment and determine what it would cost, assessment tools can help you do that. And we've partnered with Cloudomize and Cloud Physics, in addition to other technology partners, to provide assessment tools to help you determine what it will cost to run on Google Cloud Platform. These can help with discovery, comparing on-premises costs to costs in the cloud, as well as sizing, determining which shape of machine you should be running in cloud based on your actual usage. I'm going to hop over and show you that in Cloudomize. All right, so this is the main Cloudomize dashboard. Now, Cloudomize is an application you install in your environment, and it will scan your machines and determine what size they are, applications that are running on them, how much resources are being used, to help you get an accurate estimate for what it will cost to run in cloud. So let me show you here, we're on the workload tab, and you can see the total annual cost in this environment would be $162,000 for these per year for these 56 servers. And what Cloudomize has done here is shown here are all the machines that it found in the environment, and also different attributes of them, such as the operating system, the recommended instance size, and the costs for compute, storage, and networking. And one thing to point out here is that this workload tab, this is providing the cost based on your application's usage, not just on the size that the VM is in your environment. So for example, if you have an 8-core, 16-gig VM running in your environment, but really you're only using 8 gigs of that RAM, the workload view would show you the cost for 8 cores and 8 gigs. A lot of times people like to compare not only based on the usage pricing, but the exact same like-for-like shapes. And you can do that by going to the Hardware tab. In this case, Cloudomize will show you the cost of running in Google Cloud based on the shape of the machines in your environment, irrespective of your application usage. Now, a lot of companies are over-provisioned on premises, and so what you'll see then is that the cost matching like for like will be higher than if you match based on the actual usage. Okay, so that was a little bit about assessments, discovery, determining cost, now for planning. There are a number of steps in the planning phase. Now, this could look a little intimidating at first, but just going through each of them methodically will help you set up your cloud foundation so you can then perform an application migration on top of it. So let's go through a few of these steps. The first is selecting an appropriate first mover early. Now, there are technical considerations here, but also business considerations. We're going to start with those on the business side. The business characteristics of a good first mover app include not being business critical. So although it's tempting when you look at, well, we should move to the cloud, we want to get the benefits of running in the cloud for all of our applications, and especially our business critical applications, we recommend that you start by moving ones that are not business critical. Now, one of the reasons for that is that you can build momentum within your organization with each application that you migrate. And so by starting with ones that are simpler, you can show your organization the value of running in cloud and then build the momentum to move larger and more critical applications. Another factor on the business side is an application that is managed by a central team. If you have to navigate different organizational boundaries, in addition to moving to cloud, that can make that first app migration harder. Oftentimes, these applications that are managed by a central team may be managed by the IT organization rather than a business unit. Another attribute is compliance. If you have applications that have particular compliance challenges, Google Cloud has a number of capabilities to help you maintain compliance. For example, the Colorado Center for Personalized Medicine uses Google Cloud to help them meet HIPAA compliance. We can also help customers meet compliance around geographic requirements for data storage or control over encryption keys. Now, these apps with compliance challenges can be a lot of fun, actually. They just shouldn't be the first ones to move to cloud. The last business characteristic is that the application should be able to afford a cutover window. As you'll see in a demo later, that's a few minutes of downtime that you can do from cutting over from your on-premises or colo into the cloud. Oftentimes, you can do this as part of your monthly maintenance window for the application. So from the perspective of your employees or your external users, there doesn't need to be any additional downtime. So that's on the business side. Now let's look on the technical side. A good first mover application is one that has few dependencies. So if you have, for example, a component or a database that's tied to a number of different services and a number of different applications, it's probably best to hold off on moving that one. You can move it later, but let's not move that one first. A second characteristic is those that are stateless. So if you have, for example, web servers that are serving up web pages, or you have, say, workers that are doing a bunch of big data analysis and they funnel off their results to shared storage, those could be good ones to move first into the cloud. Another factor is those that don't require as much data to be migrated. Now, we love technically challenging apps and those that involve a lot of data. As an example, Evernote moved over 3 petabytes of data to Google Cloud Platform. The point here is just that those apps don't need to be the first ones to move to cloud. So here is an example of an application showing the dependency diagram of different components. And you have, on the left-hand side, a group of users and also some external applications that are calling into the software. And a good first mover in this example would be this JavaScript web app near the upper left. So it's one that has relatively few dependencies. It's also one that is used only by end users and not also by external applications. So this is one that would be a good first mover candidate. By contrast, that blog post pool in the middle has a number of inbound and outbound dependencies. It's also one that will affect users and external applications, so we'd recommend moving that one later. There are planning tools that can help you identify application dependencies and move groups if this is something you don't already have in your organization. I'll hop over to Cloudomize and show you that. All right. Back in Cloudomize, this was the dashboard where we looked at the costs of migrating these machines to cloud and what was running on those machines. Now let's go over to the Migration Planner. So this canvas shows 4 different environments that include the machines that Cloudomize discovered in our organization. We have development, production, QA, and shadow IT. So let's start with development. Within the development environment, we have a number of different applications. Now, Cloudomize has run this assessment for approximately 2 weeks. So it's observe what the dependencies are between different servers and different applications. If we look at this PHP web app, for example, you can see that it's comprised of 6 servers. And if we go to the application interconnectivity panel, we can look at all the observed dependencies. Now, these are not theoretical dependencies. These are ones that CloudMice has observed in the environment. You can see that is a lot of edges. That is a highly connected graph. If we zoom out, you'll see not only is it a large number of dependencies, but also this application that's in the development environment has dependencies on production, QA, and shadow IT down there at the bottom. So this would not be a good first mover app. Let's look at a different application. So here's the FileZilla app. This is comprised of 2 servers. And again, we'll look at the dependencies between them. And you see these are very contained. Not only are they all within the development environment, they're also all within that application unit. So this would be an example of a good first mover. The way that you could get started on your move from CloudMice is you go up to the tools and say migrate your environment. Then I'll choose the workload view, go into development, and choose FileZilla. This is the application that we saw had relatively few dependencies. So when I hit apply, now CloudMice lists out the machines, the type that they'll run as in Google Cloud, and so on. And I could download this as an Excel file and use that Excel file as input to Cloud Endure, one of our migration partners, to perform the actual migration. Now we've identified a good first mover. The next steps are about setting up the cloud foundation. So we'll start by establishing a user identity on the cloud. For a number of companies, you already have an existing LDAP server, like Microsoft Active Directory, running on premises or in your data center. And you can continue using those identities with Google Cloud by installing the Google Cloud Directory Sync tool on your AD server. This will sync up the accounts as well as the groups from Active Directory into Google Cloud, and you can use those same identities to assign people permissions to access cloud resources like virtual machines or cloud storage. The other option is connecting with a cloud identity service. So if you're running, for example, Okta or Ping in your organization, they have connectors that will connect into Google Cloud, and you can continue using those identities in Google Cloud Platform. Either way, the takeaway is use your existing identities, don't create something new. The next step is designing your resource hierarchy and your policies for access management. A lot of organizations have a particular structure for particular business reasons. For example, if your organization has a few different departments, and each department has a few different teams, and each team has a few different products or services, you can model that in Google Cloud Platform. The benefit of modeling your organization's hierarchy in your cloud resource hierarchy is that now you maintain centralized control very easily. For example, if you want to allow a small number of network admins to have permission to modify all networking resources, no matter where they are in your environment, you could grant that small group the network admin role and the security admin role on your organization's top node. And then any project within your organization, they'll be able to manage networking resources. The IAM policies that you set at one level of the hierarchy are inherited down. So you can maintain that centralized control easily. Even if someone springs up a new project without notifying you, you can know that it's still within your realm of management. Additionally, each project, the yellow circles in this diagram, provide a trust boundary and isolation. So you can grant, for example, a larger group of developers and admins access to this test project down here for product 1, and grant a much smaller group access to the production version of that same project. Once you've designed your hierarchy and you have established your identity in Google Cloud, you can then define groups and grant those groups identity and access management roles, or IAM roles, so that they have permissions to do what they need to do in your Google Cloud project without them being able to do everything that you don't want them to. For example, if you want a group of system admins to be able to start and stop VMs, but not to, for example, delete a firewall rule, you can grant an IAM role for just those permissions and exclude the other operations. There are other steps in planning that we don't have time to cover in this session, but I want to mention for completeness. Those include designing a network topology, which will let you establish connectivity between your current environment and your Google Cloud environment, and also setting up your monitoring and audit logging strategy. I've talked a little bit about assessment, now planning, now we're on to deployment. There are 4 steps in the deployment phase. There's creating that cloud foundation. So steps 2 through 6 from the planning section, starting with identity and going down to monitoring and audit logging, those together comprise your cloud foundation. You'll set that up first, and then you can migrate individual applications into that environment. I'm going to show here a demo of step 2, migrating an application, and also step 3, testing the application. And then what you would do is, if that test works for you, if you see that you're getting the performance you need and that everything is working smoothly, you can then cut over to cloud. We have 2 migration tools for you that are free for you to use to migrate to Google Compute Engine: Cloud Endure and Velostrada. My colleague Shan has a session in track 1 on Velostrada, so I'm going to focus here on Cloud Endure. All right, so let me set up the scenario here for you. We have a demo source project. This is a Google Cloud Platform project for the purposes of this session, but in your environment, that would be your on-premises servers, whether physical or virtual, or it could be your machines running in another cloud provider. In this source, I have 6 different servers running. I'm going to focus first on these 2 in the middle: WP1 app and WP1DB. These together are a 2-tier WordPress application that we're going to show we can migrate into Google Compute Engine using Cloud Endure. I've also set up a destination project. This is where the machines we migrated into. You can see that now there's 1 virtual machine running there, and that's the Cloud Endure replicator. This is a virtual machine that Cloud Endure sets up to manage the migration and will create the virtual machines in Google Cloud Platform. So far we have just that one, and none of the WordPress instances are there. So now let's go over to the Cloud Endure console. You can see there are 2 machines here, WP1 app and WP1DB. These are the same as the ones from the source project. Both of these are in continuous data replication mode. What this means is that as the app is running live on premises in my source project, Cloud Endure is continuing to send up changes that happen live. I'll show you how this works. Let me go over to the source project. I'll grab this IP address. All right, this shows you a WordPress site, and we have only 1 post. The all-important first post is there. Now I'm going to log in and create a second post. We'll call that Cloud on Air. There we are. Okay, there's our second post in the source projects. This would correspond to your on-premises environment. Now let's go over to Cloud Endure, and we can walk through how Cloud Endure works quickly and then show you that test cutover. So Cloud Endure defines a blueprint for each instance that you're going to move to Google Cloud. This includes information like what kind of machine it should be when it's running on Google Cloud, the subnetwork to connect to, in this case I just chose the default, as well as the private IP address. And here I specified a particular private IP because that's the one that the WordPress app server is expecting to communicate with. You can also specify here the type of disk. I chose an SSD. All right, now I'm going to take both of these servers and launch them as a test into Google Cloud. While I'm doing this, the app is still running in the source. You can see these check marks are still green. And then Cloud Door is going to begin the process of creating the test versions of those instances in the destination project. While that's happening, let me also show you how easy it is to install the Cloud Endure agent in our servers. So what's happening here, as you saw in Terrence's session earlier, is that Google Compute Engine is generating an SSH key pair. So whenever someone hits that SSH button, as long as they have the proper permissions to SSH into the machine, then Google will generate a key pair. It will push the corresponding key, the public key, into the virtual machine. I don't have to enter the private key. I don't have to upload a file. It just works because I have the right permissions, and the SSH button will make sure the key transfer happens automatically. So now let's look at our servers. I wrote a 2-line script to install the Cloud Endure agents. This is on a second copy of the WordPress server. And this is the second copy of the application layer for that server. So now we've got the agent running on the second copy, and we're also creating the test version of the first app, the WP1 app, in our destination project. So we'll let that run. I'll hop back and talk about optimization, and then come back to check on the migration. All right, optimization. Up to 35% of cloud spending is wasted, according to RightScale's 2018 State of the Cloud report. There are a number of things that Google Compute Engine does to reduce wasteful cloud spending. The first is automatic sustained use discount. The longer you leave a VM running, the bigger discount we apply, and it's automatic. You don't have to check a box, enter a promo code. You can't forget to get the discount. On average, we see customers saving about 21% off of the list price for doing nothing. The second way that Compute Engine saves you money comes as a point of comparison. Some cloud providers only have fixed VM configurations. And so you have to choose the fixed shape that is at least as large as what your application needs. But application needs for CPU and memory can vary, and they can vary a lot. So you may end up buying more CPU or memory than you need just because you have to round up to the next largest VM size. For example, suppose that your app needs 16 cores and 40 gigs of RAM. Well, some other providers offer 16-core 32 gigs of RAM as one shape and 16-core 64 gigs of RAM as the other. Well, with these choices, either you have to deprive your app of memory or you overpay for memory you don't need. With Google Compute Engine, we offer custom machine types. You can choose the number of cores and the amount of memory that you need, so you don't pay for anything that you don't. For example, that 16-core 40 gig VM that I mentioned in the last slide, sure, you can run that on Compute Engine. Sometimes apps need memory that isn't a clean power of 2, and that's okay. And it's pretty easy to do this in Compute Engine. When you're creating your instance, you just drag the sliders to how many cores you need, how much memory you need, and then you get the machine that is the right size for your application. What's even more magical, though, is that we can also help you right-size your virtual machines by observing how much memory and CPU is actually used, then proactively tell you which ones can be resized to save money. Let me show you a demo of that. Okay, so here's an instance You can see here the large instance. We've noticed that I could be saving $333 a month if I resize that. And you see similarly recommendations for other instances in this project. If I click on that, I can see I'm currently running 16 cores, 60 gigs of RAM, and from observing the application and the resource usage within that machine, Compute Engine has recommended I size down to 6 cores and 20 gigs of RAM. So when I'm ready to do that, I can hit apply. That will restart the instance quickly, change the shape, and now I'm saving money without having to do any additional calculation or analysis on my part. All right, let's go over to our destination project. And here you can see the WP1 app and the WP1 DB server that we had in our source. Now remember, in the source, I went and created that additional blog post. We should see 2 blog posts here in our destination because Cloud Endure is migrating the changes of the live running VM. All right, and there we are. Now we see that second blog post, the one that I created on the source project, the on-premises project, and is now showing up here in our destination or our cloud project. So we've got the test failover, and we showed that it will copy data even from a live running application. The other thing we can see is these 2 servers that I installed the agent on during our session, WP2 app and WP2 DB, these are both now in the data replication phase doing their initial sync and are about at 50%. And in a few minutes, they would also be in continuous data replication mode, which means that we'd be able to do that same sort of test failover, make sure it's running well in the cloud, and then if we see that everything is going well, we can do the permanent cutover. So I showed you here how easy it is to install the Cloud Endure agent and get your replication and migration started, and also how to perform a test failover so that you can, even while you're making changes to your on-premises environment, you can see that it's running well in the cloud before you make that final cutover decision. So in summary, I've talked about the 4 different phases of migration: assess, plan, deploy, and optimize. And one of the key takeaways is to start with that good first mover application. Also, the time that you spend on the cloud foundation, those 6 steps that I showed you, that will speed up each additional app that you migrate into Google Cloud. And finally, we have tools that can help you at each step of the way. For more information on how to migrate, those you can go to cloud.google.com/migrate. So now I think we're going to take a transition for Q&A. So I'll be back in about a minute, and we'll go through some questions. All right, welcome back. We have a few questions here. First, when should I consider using a managed service versus a direct lift and shift? So this goes to that assessment phase. This depends on the business needs that you have and also what's motivating your move to cloud. For example, some companies that we work with are on a tight schedule to get out of their data center, get out of their colo. And in that case, we recommend that you do the direct lift and shift so that you meet that business objective of getting out of your data center, and then you can, over time, refactor and switch to a managed service. For example, Cloud SQL to replace your MySQL Server VMs. On the other hand, if the value of that managed service is very high to your business, and you're not under that time pressure, then you should consider migrating directly to the managed service. An example here is Spotify and their use of our big data and analysis tools. So if you've seen our case study of Spotify, you can see how vocal the Spotify engineers were about the value of services like BigQuery. So for them, moving directly to the managed service can make more sense because that is a key part of their business and a lot of the value they derive from cloud. All right, next question. In addition to sustained use discounts and right-sizing VMs, how else can I make sure we don't overspend? So this is one of the common questions that comes up because the spending model is different on premises than in the cloud. There are a few additional things that we provide to make it easier for you to control the spending of your organization. One is that we have budgets that you can set. So you can specify a particular dollar amount to make sure you don't go over that in a particular billing cycle. Secondly, we offer billing alerts. So before you even get close to that figure, maybe you want to get alerted at 20% or at 50%, and billing administrators can configure that as well. Additionally, you can use IAM permissions to limit which operations employees can perform. So for example, you can give someone permissions to only read certain cloud resources and not make changes that would incur additional costs. So that's a third way you could do it. Next one, what can I do with apps that are running on Windows Server 2003? So we understand that there are a number of companies that are running applications still on Server 2003, even though that's been out of support for Microsoft for several years. But our goal with Google Cloud Platform is to meet you where you are and help you migrate to cloud. To that end, yesterday we announced the general availability of running Windows Server 2003 on Google Compute Engine. And you can migrate your Server 2003 R2 VMs in from your on-premises environment to Google Compute Engine using partners like Cloud Indoor. All right, next one very quickly, as we're running low on time, how can I make sure employees don't have too much access in the cloud? Custom IAM roles is the short answer to this. You choose the methods that they should have access to and give them only those permissions. All right, there, now we have to wrap up. Thank you very much for joining the session. Please do remember to fill out the feedback form. We love to hear from you and we love data. Hope you enjoy the rest of the conference.